Hi guys, I'm going to show you how to model a simple boost converter in MATLAB Simulink. A boost converter is a basic DC to DC step-up converter, which means that your output voltage is greater than your input voltage. So the first thing you want to do is open up MATLAB, go to new Simulink model, and let me just expand this here so we have a bit more space. Then go to libraries, and the first thing we want to do is add Power GUI. Power GUI basically allows to model power system components in Simulink. So this is very important. So let's just place it over there. Next thing we need is a DC voltage source. And we are going to need our energy storages, so inductor and capacitors. So we go to RLC branches here, and we'll use one for inductor, one for capacitor, and one for our load resistor. We are also going to need a switch. In this case I'm going to use a MOSFET, but you can also use an IGBT. Power MOSFETs are better at higher frequency switching. Next thing we need is our diode. So we'll just use this one. So what else do we need? We need to measure voltage. So we'll use a voltage measurement to measure voltage across the load. We are also going to need a pulse generator, so we can switch the MOSFET on and off at very high rate. So use a pulse generator as well. And I think that's about it, So let's just connect everything together now. So a DC voltage source, we'll just put 5 volts for now. Then we're going to need our inductor. So if you double click on that code, this property box will open, and choose L, and 1 millihenry seems fine for now, and connect it. Then we're going to need our diode. Let's connect our diode up. We need our switch, and if you do Command R on a Mac or Control R on a PC, then you will be able to rotate this. And then just connect it up now to our voltage source. We need a pulse generator to connect to the MOSFET. And if you open a pulse generator, so the time period we will need is around 1 over 25,000, let's say. And the pulse width, let's just start with 70% of this time. The next thing we need is a capacitor, so we'll just use C over here, and let's just put 33 microfarad for now. Command R again to rotate it, connect it across here. Our resistor load, so let's just use let's say 100 ohms for now. Command R, and while we are here I'm just going to label all these components, so it's just much more nicer, let's say, much more prettier. Now we're going to need our voltage measurement across the load. Okay, so now we are here. Yeah, we need scope as well. So if you go to the library and search for scope, here's the scope. And we can also use a display, so we don't have to open up scope every time. So this will just show you the instantaneous sort of number over there. Well, if you want to look at what happened over a time period, then you will need to look into scope. So we'll just connect this up to here. Oops. And connect the display to here as well. Okay, let me just double check my values now. This is 5. That seems right. Or most, yeah, this is very important. We need to decrease the resistance down of this MOSFET so it is as ideal as possible. Inductor is correct. Capacitor is okay. Load is okay. So okay, now we're gonna run it. So let's just decrease the time to 0.1 second because this is all we need actually. And if you open up scope and we run it here, we would be able to see what happened. Okay, so our input voltage was 5 volts and now we are getting almost 15.9, almost 16 over here. So if you and if you want to like change the grid size, then you can go over here. Sorry, go to configuration properties. If you double click, or right click properties, you can change the access limit over here. So we'll go from 0 to, let's say, 30 volts. So this is your graph for the boost converter for this particular configuration. So if you increase the pulse width duration over here, you would be able to see that our voltage at the output would increase. So now it is up to almost 24 volts over here. So as you can see, so this was our simple boost converter. By controlling the pulse width of the MOSFET, you would be able to increase or decrease the output voltage, but the output voltage cannot go below the DC source voltage, as this is only a boost converter. If you want to know how to decrease the output voltage so your output voltage is less than your input voltage, then please see my video on buck converters. The link would be in the description. So yeah, if you guys like this video and you think it was helpful, then please don't forget to click the like button and please subscribe to my channel for more awesome stuff. Thank you guys for watching.